Hi everyone, you're welcome to my YouTube channel. My name is Anderson Ikechukwu Nathaniel. I am a science tutor and also a mathematics tutor. By the very special grace of God, I have an experience of over 8 years in teaching sciences and mathematics. I have tutored a lot of students who have gained admission into different universities across Nigeria, and also some of my students have gained admission into foreign universities via SAT examination through my tutelage. It's a very great honor to be with you live here on my YouTube channel. On my YouTube channel, we'll be considering 3 subjects that are a cause for worry for students. It has actually posed difficulty for a lot of students. And these 3 subjects that we'll be looking at on my YouTube channel are chemistry, physics, and mathematics. Chemistry, physics, and mathematics. But today we'll be looking at chemistry, and under chemistry we'll be looking at one particular subject, one particular topic rather, that has been a problem for a lot of students because of their background knowledge. And this topic is known as naming of organic compounds. So we're looking at chemistry today, and then on chemistry we'll be looking at naming of organic compounds. Naming of organic compounds. It will interest you to know that a lot of students who are anticipating to write the JAMB based examination, which is known as UTME, that's Unified Tertiary Matriculation Examination, and even a lot of students who are anticipating to write the WAEC, that's the WAEC based or NECO based examination, do not know how to name organic compounds. But then that is nothing to be worried about, because here on my YouTube channel, after this lecture, you would have a first class hand, or you would have a first class idea or a first class knowledge on how to name organic compounds. So there shouldn't be any worries at all. Now, there are certain things you need to know before you can name organic compounds. And what are those things you need to know? You need to know the numbers, the names for the numbers of carbon chains that are linked together. So let me start with this. When you see one carbon chain, it is known as meth. When you see 2 carbon chains linked together, it is known as F. When you see 3 carbon chains linked together, it is known as prop. When you see 4 carbon chains linked together, it is known as but. When you see 5 carbon chains linked together, it is known as pent. When you see 6 carbon chains linked together, it is known as X. When you see 7 carbon chains linked together, it is known as ept. When you see 8 carbon chains linked together, it is known as oct. When you see 9 carbon chains linked together, it is known as non. And when you see 10 carbon chains linked together, it is known as dec. Yes, we have carbon chains that are more than 10, but we're not going to be looking at that, as we're going to restrict ourselves to 1 to 10 carbon chains for the sake of your exams, for those of you who will be writing the upcoming JAMB examination. So we won't want to bother ourselves with carbon chains from 11, 12, and the rest of them. So let's just restrict ourselves to 1 to 10. So remember, carbon chain 1, a carbon chain that has 1 carbon is known as meth. Carbon chains that have 2 carbons is known as F. Carbon chains that have 3 carbons known as prop. Carbon chains with 4 carbons known as but. Carbon chains with 5 carbons is known as pent. Carbon chains with 6 carbons is known as eggs. Carbon chains with 7 carbons is known as hept. Carbon chains with 8 carbons is known as oct. Carbon chains with 9 carbons is known as non. And carbon chains with 10 carbons is known as dec. Good, dec. Now you know this. Now, there are rules that govern naming of organic compounds. There are rules that govern naming of organic compounds. And we're going to be looking at those rules. The very first rule that governs naming of organic compound is that you are expected to locate the longest chain. You're expected to locate the longest chain. You're expected to locate the longest chain. In locating your longest chain, there isn't any particular way, as I've heard from many of my students in the past, from what they were taught by their teachers, that when locating the longest chain, you must always count from left to right. Please, this analogy is totally wrong. When naming of your organic compounds, in the quest to locate your longest chain, you must consider all possible linking of your carbon chain. That means you must consider all possible counting. Now, I will explain that to you. So let's take an example. Let's say I have a compound like this. Now, mind you, these are hydrogen. Every time you see these, they are hydrogen, except when giving another compound. So if I was giving another compound outside hydrogen, I would definitely write the compound attached to it. So when you see these like this with no element attached to them, it means that the elements attached to them are hydrogen. So now, but let me put that so that a lot of you will understand. So this is hydrogen, 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 hydrogen. So now note that we intend to locate our longest chain. So in the quest to locate our longest chain, we must do or count in every possible way. Just like in mathematics, you talk about combination. In mathematics, you talk about combination. So combination has to do with selection. So we must select the carbon chain that would give us our longest numbering. The carbon chain that will give us our longest what? Chain. Now let's proceed. So I would count from left to right and see if left to right would give me my longest chain. So I have 1, 2, 3, 4, 5, 6, 7. So from left to right or right to left, I have 7 carbon chain. Now you don't end there, because you also have another, you could also count in another way. So let's count from left to down. Left to down. So let's count from left to down. 1, 2, 3, 4, 5, 6, 7, and 8. So from left to down, we have 8. Now let's count from left to up. From left to up. So permit me to clean this so that it doesn't confuse anybody. I'm going to clean from the left to right. But remember that left to right, we have how many? 7. So we can just write it down here. Left to right. we have 7. Okay, left to down or down to left, whichever way. Left to down, we have 8. So we have 8 from left to down. So I'll be cleaning these numbers. Okay, so let's count. So we've counted left to right and we've counted left to down. So let's count from left to up and see how many we have there. So we have 1, 2, 3, 4, and 5. So from left to up, we have 5. Now let's count from down to right. Down to right. So from down to right, let's count. 1, 2, 3, 4, 5, 6, 7, and 8. So down to right, we have 8. Now, so that means in the quest to locate our longest chain, we have 4 ways or 4 counts. So amongst these 4 counts, we're going to locate which of these counts give us our longest chain. Now you can see that left to down gave us 8 as against 7 that was given from left to right. Left to up gave us 5, and down to right, from down here to the right side, also gave us 8. So we have 2 counts that gave us our longest chain. 2 counts that gave us our longest chain. Since we have 2 counts that gave us our longest chain, we can choose one between them. We can choose what? One between them. We can choose one between them. So I would rather choose down to right. You can also choose left to down. It's still the same thing you're going to get. So when you have identified your longest chain, like I tell my students that I've taught in the past and I still tutor now, I tell them, use a pencil to box your longest chain. Use a pencil to box your longest chain. As we go in our rules that governs naming of organic compounds, you will get to understand why I always tell students to use or advise students to use a pencil to box their longest chain. There's a reason for that, which will be explained as we move further. So like I said, I would prefer to go down to right. So since I'm going down to right, I'm going to box my carbon so I could take it down to right. Now, this is my longest chain. So that means, what number is my longest chain? What number is my longest chain? 8 is my longest chain. 8 is my longest chain. And as we agreed, or as we saw based on our counts, that we have 2 counts that gave us the longest chain, either from left to down or down to right. But I decided to go down to right. Like I said, it is still the same answer you're going to get if you use from left to down. So after doing this, what do you do? What is the name for 8 carbon chain? The name for 8 carbon chain is known as oct. So I'll write that down. So my longest chain here is known as oct. My longest chain here is known as oct. Now, like I said, we are building up, so I'm not going to rush in writing everything. My longest chain here is known as what? Oct. Number 2 is that you need to check for presence of a functional group. You need to check for presence of a functional group. You need to check for the presence of a functional group. What is a functional group? A functional group can be defined as an atom or group of atoms or elements that are what? Common to the homologous series. So when you talk about homologous series simply refers to family of organic compounds that follows a regular structural pattern in which each successive member differs by a molecular formula of CH2. I'm going to take that again. Homologous series can be defined as a family of organic compound that follows a regular structural pattern in which each member of that family differs by a molecular formula of CH2. Okay, so remember we said functional groups are atoms or group of atoms that are particulate or common to a homologous series or common to an organic compound or organic family. Now, for you to know functional group, I'm going to list out there are things you need to know about this functional group. Now, number one is that there are functional groups that serves as the prefix, and then there are functional groups that serves as the suffix. For functional groups that serves as the prefix, by prefix we mean in front, like you have your name. In your names you have your surname. Your surname is known as a suffix. Your own name is known as the what? As the prefix. Your surname is your what? The suffix, which is the last name or which is your last name. Your name is known as the prefix, which is your first name. So we have functional groups that serves as first name, and we also have functional groups that serves as surnames. We also have functional groups that stay at the middle, that serves as middle names. We're going to look at that. So what I'm going to do for you is that I'm going to wipe this off, or I'll clean my chemistry and naming of organic compounds, and I'm going to write out those functional groups that serves as suffix and those functional groups that serves as prefix. So remember that we have this compound here. So later on we'll draw this compound. Just know that the longest chain. So we're dealing with this compound. So functional group that serves as suffix. Functional groups that serves as suffix. So what I will be doing is I'm not going to clean this our compound, because this is our example, or this is our example through which we're actually using to explain naming of organic compound. So what are the functional groups that serves as suffix? So number one of those is the straight chain. Now, when an organic compound has straight chains all through, when an organic compound has straight chains all through without any other functional group, we call that organic compound the ane family. So it ends with ane. Ane is referred to the family of alkane. The ane is from the family of what? Alkane. The ane is from the family of alkane. Now, in a situation whereby we have a double bond present in our organic compound, we refer it as ene. And the ene hails from the family of alkene. It hails from the family of alkene. Then we also have triple bonds. So when you have a functional group, or when you have an organic compound that has a triple bond, even if the single bond is present, it's going to double bond, triple bond would always override the single bond. When we say override, it means that it would always take over from the single bond. So the only time the single bond is considered is when you don't have any other functional group at all. So when you have a triple bond, we call it yin. And this hails from the family of alkyne. So this is called yne. Triple bonds are called what? Yne, and it comes from the family of alkyne. Okay, so you've written that. We're going to go to more, so I can clean that. Remember that we don't want to clean this because this is our study point. We're using this as an example, so we don't want to clean our example. Okay, so I believe you have written that now, so I can clean that. Now we have other functional groups, OH. The OH is known as all. Is known as what? All. But what I'm going to do for you, because I've seen many students do a lot of mistake, which I would point out early, is that I'm going to add, I'm not supposed to do this, but I'm not supposed to do this for you, but I want you to know that the all is the end name of what? The OH, and it comes from the family of the alkanol. It comes from the family of the alkanol. So you see the way I wrote it here, alkanol. I want you to know that in the presence of single bonds, is going to end as anol, But what I want you to know is the last name that you add, which is what? All. We're going to look at how it actually occurs here. Then we also have the COOH. Another way of writing this COOH is by saying carbon is double bonded to oxygen and single bonded to hydroxyl. So this is different from this. This one is not double bonded. The O and the H goes together for the alkanol family. Now this here goes with what we know as oic, and it's from the family of alkanoic. Then we also have another one, which is CHO. This CHO differs from OH. So the CHO can also be written as this: C double bond O, single bond to H. Now this is known as the al family, and it comes from the alkanal. It comes from what? Alkanal. So we have OH, which would always end with all. It comes from alkanol. We have COOH, which is the oic. It comes from the alkanoic family. We have the CHO, which is the al, comes from the alkanal family. We still have more. So these are not the only ones. So I'll clean this. So we've talked about 6 now. So we have number 7. We have CO, which is also known as C double bond O. C double bond O. Now this is from the family of 1. We call it 1. So this ends with 1 rather. It ends with 1, and it comes from the family of alkanone. It comes from the family of alkanone. Note that we're using the last name. These are the suffix. These are our suffix. So that's why it's ending with 1. Number 8, we have the COO, which can also be written as C double bond O, single bond O, and this ends with OH. It ends with OH. It comes from the family of alkanoate. It comes from the family of what? Alkanoate. It comes from the family of alkanoate. It comes from the family of the alkanoate. Okay, so I guess you've all written that. So I'm going to clean this, and then, like I said, we still have more. We still have more functional groups that serves as our suffix. So number 9, we have NH2. So whenever you see NH2, it ends with amine, and then this is the family, this comes from the family of amine. That's the family of amine. Number 10, we have CONH2. This ends with amide, and it comes from the family of amide. So these are the functional groups that serve as suffix. These are the functional groups that can be used as what? As suffix. So we're going to go into functional group that serves as prefix. Functional group that serves as what? As prefix. So there are certain functional groups that can exist as both suffix and prefix. So I'm going to start with such functional group. Remember, we saw OH as a functional group. Sorry, I said functional. It's supposed to be functional group. It's supposed to be functional group. Sorry for that mistake. Remember that OH was amongst the functional group that served as a suffix. And here we can also see OH serving as a prefix. That means coming as a first name. Now when OH stands as a prefix, it is called hydroxyl. It is called hydroxyl. Now, like I said, this is also from the family of the word alkanol. From the family of alkanol, but this time around, it is not standing as a suffix, rather it is standing as a prefix. So when it stands as a prefix, it doesn't end with the "ol", rather it comes with the name hydroxyl. Again, we also have COOH, which is from the family of alkanoic organic compounds. It's from the family of alkanoic organic compounds. But again, it doesn't end with oic because it is not standing as a suffix. Rather, it is standing as a prefix. So as a prefix is called carboxyl. It's called carboxyl. Now, we're going to now look at functional groups that do not exist as suffix. They are naturally just prefix, and they are called the haloalkanes. Haloalkanes. So the symbol for haloalkanes are X. However, when we talk about haloalkanes, the haloalkanes refers to halogen groups. The haloalkanes refers to halogen groups. So examples of our haloalkanes are fluorine. So when you see F amongst your organic compound, we call that fluoro. When you see Cl, we call that chloro. When you see Br, we call that bromo. And when we see I, it's called iodo. It's called iodo. So these belong to what? The haloalkane family. They belong to the haloalkane family. So, like I said, if you see F present in your organic compound, we tag it as what? Fluoro. When we see Cl present, we tag it as chloro. And when we see Br, it's tagged as what? Bromo. And when we see I, it is tagged as iodo. Now we'll come to the last part, or last set of organic compounds, or functional groups rather, that do not exist as prefix nor suffix. Rather, they stay in the middle. They stay in the middle. So Yes, this is not in your textbook. This is not in your textbook, but I needed to break it down for you so that you understand them. And we have only just one functional group that exhibits these traits. And what is that functional group? When you see this, when you see this always exists as oxyl, and it's from the family of what we call alk, oxyl alkane. Oxyl alkane. So you can see the oxyl here. It stays where? It stays at the middle. It stays at the middle. It stays at the middle. So when you say arc, it could be a branch or it could be an aryl group. Aryl groups are cyclic group. They're cyclic group. They're cyclic group. It could be an alkyl group, which is a branch. So we're going to stop here today. I'll plead with you to join me on my next section as we continue to explore the rules of naming of organic compounds. Please don't forget to share, click the subscribe button, and also like my videos. And also reach out to your friends who are out there who don't have the opportunity to go to very good schools. They can learn chemistry, physics, and mathematics right from the comfort of their homes. So when we meet again, I say goodbye.